In this presentation, we're going to look at the properties of functions. This is the second example of a few examples related to whether or not a function is one-to-one, onto, and invertible. So let's look at our function here. We have the function f is defined by the rule f of x equals the absolute value of x plus 1. Importantly, we're going to look at the domain here. Domain is integers, and the codomain is also integers. Now, let's evaluate this here for, let's say, f of 2. In that case, we have the absolute value of 2 plus 1. That's the absolute value of 3, which is 3. Let's evaluate it for minus 1. In that case, we would have minus 1 plus 1, and that is equal to the absolute value of 0, which is 0. F of minus 2, I'll just give the answer to this one. We would get minus the absolute value of minus 1, that is equal to 1. So there's a few evaluations for various values of the domain. We would have 0, 1, 3, 0, and 1 corresponding to 2, minus 1, and minus 2. So what is the range of this function? This is an important matter. We can only have positive integers. So this could let's look at the codomain first. This is negative positive integers and also 0. That is the codomain. But the range of this function is positive integers, which we denote z with that plus in as a superscript, also 0. 0 is not actually a positive integer, it is not a negative integer, it is just 0. So the range of the values we actually might describe as a set. The range is the union of positive integers and 0. Now, importantly, the range and the codomain are not the same. So is the function onto? No. Codomain, codomain is positive, all integers, range non-negative integers. Not the same. So the answer is the function onto? Well, the range and the codomain are not the same, so the answer is no. Is this a function one-to-one? Well, we could have the absolute value of minus 3 plus 1. So let's say we're looking at f of minus 3. We would have a value there of the absolute value of minus 2, which is equal to 2. If we were to look at the function of 1, that would be 1 plus 1, that's also equal to 2. We have two distinct values that two distinct values, minus 3 and 1, and when we use the function to evaluate the corresponding element in the range, we have the same value here. So the answer is no. Distinct values of the domain must correspond to distinct values of the range. These are not distinct from one another. So the answer to that question is no. It is not one-to-one. It is not onto. So it is the case that it is not invertible. The last question is this function invertible? No. Not one-to-one, not onto. And that ends our presentation.